This is chapter 6.5, trapezoids. Your assignment's going to be pages 334 to 335, 9 through 22. Fold your paper in half vertically. All your notes, vocabulary, and examples go on the left. A trapezoid is a quadrilateral with one pair of parallel sides, as opposed to parallelograms, which have two pairs of parallel sides. Make sure you draw the picture of this. Use different colors if you have them. So the base is the top and bottom. There are two bases. It can also be the sides if you tip this vertically. And the bases are parallel to one another. They are parallel sides. So that's your one pair of parallel sides. The legs connect the bases, and they are non-parallel. This is shown in blue to help you see it, and it's written in blue. The legs are the non-parallel sides. Now, base angles are those angles that are right by the base. So for this bottom base, A and D are the base angles, and for this top base, B and C are the base angles. And there's always going to be two pairs of base angles in any trapezoid. Now we're going to talk about special trapezoids, which are isosceles trapezoids. And in an isosceles trapezoid, the legs are congruent. In an isosceles trapezoid, the legs are congruent, just like an isosceles triangle, two sides are congruent. The legs are the two non-parallel sides of a trapezoid. In the picture below, the trapezoid CDEF, DE, segment DE, is parallel to segment CF. Segment DC is congruent to segment EF. They're not parallel, they're non-parallel, but they are congruent. And in an isosceles trapezoid, the base angles, each pair, will be congruent. So angle C is congruent to angle F, and angle D is congruent to angle E. Okay, one of our objectives with trapezoids today is to find the measure of the angles of an isosceles trapezoids. The theorems we're going to use are 6.12 and 6.13. In theorem 6.12, it says if, again, deductive reasoning, if-then statements, if a trapezoid is isosceles, then each pair of base angles are congruent. So if you know that the trapezoid is isosceles, and you can highlight this if you would like, then each pair, there are two pairs of base angles, and they're congruent. The reverse of that is if a trapezoid has a pair of congruent base angles. So if the trapezoid has a pair of congruent base angles, then it has to be an isosceles trapezoid, or it has to be isosceles. Go ahead and get that written down. All right, the measure of, in number 1, we are going to be, 1 and 2, we're going to be doing page 333 checkpoint activities. We're going to find the isosceles trapezoid angle measures. So in this number 1 picture, we have the trapezoid A, B, C, and D. We know that the measure of angle D is 100 degrees. We know the theorem 6.12 says if a trapezoid is isosceles, each pair of base angles are congruent. Therefore, we know that angle C is going to be 100 degrees. So that's going to be 100 degrees. Now, we know that any quadrilateral has 4 interior angles that equal 360 degrees. So if I say 100 degrees and 100 degrees is 200 degrees. To get to 360, it's another 160 degrees. But I have two angles that are congruent, angle A and angle B. So if I divide that 160 degrees into two parts, it's going to be 80 degrees and 80 degrees. So measure of angle A is 80 degrees. Measure of angle B is 80 degrees. Okay, in number 2, your picture's down here. Your trapezoid, your isosceles trapezoid is ABCD. Base AB is parallel to base CD. You're given that there's a 70-degree angle for base angle C. So you know that the measure of angle D is also 70 degrees. The measure of angle A is 110 degrees. And so is the measure of angle B. And the way that you get that is you knew that 70 and 70 was 140. The difference if you count forward from 140 to 360, because all the interior angles are going to equal 360, you get 220, but you have to split the 220 between base angles A and B. So you divide by 2, and you get 110 degrees for base angle A and 110 degrees for base angle B. Okay, our second objective in Chapter 6.5 trapezoids is to find the length of the mid-segment of a trapezoid. We're going to actually look at page 333 again, the checkpoint activities, and it's going to ask you to do just that. It will say find the length of the mid-segment of the trapezoid, but in this case it'll be the trapezoid specifically MN, because that is the mid segment. On number 4, on the checkpoint activities at the bottom of page 333, you have a trapezoid that could be isosceles, but is not necessarily. It does not have to be an isosceles trapezoid. So we have our two legs. We have one base that is 14, another base that is 8. Please note that they are parallel. The bases are always parallel. The legs are the non-parallel sides. However, when you cut them in half, so on the segment, the mid-segment is MN. When you cut those legs in half, you get two congruent parts where the M is, and you get two congruent parts where the N is. The formula for the mid-segment of a trapezoid is to take the sum of the bases, so you add up the bases, and take half of them. That's the one they will give you in the textbook. But you can also, taking half of something is like dividing by 2. If you take half of 10, you get 5. 10 divided by 2 is 5. So you can take the sum of the bases, add the two bases, and divide by 2. So in number 4, we take 8 plus 14, top base, bottom base, divide by 2, and we get 22 divided by 2, which equals 11. So MN, segment MN, that's the mid-segment, equals 11. Okay, so we continue on with checkpoint activity on the bottom of 333. We've done number 4. We're doing number 5 now. You have a trapezoid that is somewhat tilted. It's vertical, so the bases are 10 and 6. They're going vertically, which is a little different. You add those bases, 10 and 6, to find the midpoint of the midpoint segment, which is MN, and then you divide by 2, because the midpoint segment is the average of the two bases. 16 divided by 2 is 8, so mid-segment MN is 8. For number 6, you take the two bases, 24 and 18, find their sum, which is 42. You're finding the average of those two bases, so you divide by 2. You have 42 divided by 2, which is 21. The mid-segment has been proven to be the average of the two bases, so segment MN equals 21.